6.2 Properties of Parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel, hence the name parallelogram. It's in the name. In a quadrilateral, opposite sides do not share a vertex, and opposite angles do not share a side. You can abbreviate parallelogram with the symbol like this. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So if you know that it's already a parallelogram, then you can assume that its opposite sides are congruent. Consecutive angles. Angles of a polygon that share a side. So consecutive angles would be like consecutive angles would be like angle A and angle B. They share a common side. Or you could say A and D, they share a common side. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So in this case, if you know that it's a parallelogram, you know that its consecutive angles will be supplementary or add up to 180. So in this case, angle B and angle A added together make 180. Angle B and angle C added together make 180. Angle C and angle D added together make 180, and so on. In question 1, what is the measure of angle R in parallelogram RSTU? Well, R is here, and so we know that these are consecutive angles. So to find R, we would just take 180 minus angle S, which is 71, and you're going to get the measure of angle R is 109. Question 2 is a little trickier, but not much. We know that these two angles are consecutive. We also know that these two angles are consecutive. So we can go ahead and set these up accordingly. So for the left, we'll take y plus 10 plus 2y plus 5 equals 180. Combine some like terms here. We got 3y plus 15 equals 180. We'll subtract 15. We get 3y equals 165. Divide by 3. Y in this case is 55 degrees. Or y, yeah, 55. And then to find x, we'll do the same thing. We'll take 4x minus 5 plus 2x plus 5 equals 180. Combine some like terms. 6x equals 180. Divide by 6, you get x equals 30. And that's it. Theorem 6.5. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So if you know that it's a parallelogram, you can assume, or you can pretty much guarantee, that the opposite angles will be congruent. So in this case, B is congruent to D, and C and A are also congruent. Opposite angles kind of means diagonal from one another. So we use this information to solve these problems. Here we know that this angle here and this angle here are opposite angles. So to solve for x, we're going to take 3x plus 26 equals 4x. We'll move the x over. We get x. In this case, we subtract 3x over. We get, there we go, 26 equals x. Then to solve for y, we should recognize that this angle and this angle are opposite angles, so they're congruent. So we've got 5y plus 21 equals 7y minus 1. We'll subtract 5y over, we get 2y, add the 1 over, 2y equals 22, so in this case y equals 11. Question 2 goes back to the base information for a parallelogram. Opposite sides are congruent. So to solve this, we'll take 3x plus 1 equals 5x minus 1. We'll subtract 3x over, add the 1 over. You're going to get 2x equals 2. In this case, x equals 1. And then to find y, we'll do the same thing. We know they're congruent. So that's 2y minus 9 equals y minus 2. Subtract y over, you get y. Add 9 over, you get 7. So y equals 7. a quadrilateral is a parallelogram, then its diagonals bisect each other. So if we know that a quadrilateral is a parallelogram, then we also know that the diagonals of that parallelogram are going to bisect each other or cut themselves into two equal parts. So in this case, AC bisects BD, creating BE congruent to ED, and BD also cuts AC, so AE is congruent to EC. This is where things get a little trickier because now we're dealing with different variables. It's not always going to line up the way we want it to. So if we look at the example here, we know that this line and this line segment are congruent. So A equals 2B minus 8. We also know that this line and this line are congruent. So that means we've got A plus 2 equals B. The only way we're going to be able to solve this is if we use systems, and in this case, substitution. So I'm going to substitute what A equals in for A in the other equation. So in this case, our new equation becomes 2B minus 8 plus 2 equals B. I'll combine terms like terms here. I've got negative 6. I'll subtract the 2B over. I've got negative B equals negative 6, which tells me that B equals 6. Now that I know what B equals, I'll plug it back in up here to find A. So 2 times 6 is 12. 12 minus 8 is 4, so A equals 4. Here we want to find x and y in each diagram. So once again, we have a parallelogram, and the diagonals are bisecting each other. So we'll start off by setting this equal to this. So x equals y plus 2. In the other one, we've got y plus 10 equals 2x minus 8. Once again, I'm going to use substitution. I'm going to take what x equals, and I'm going to plug it in for x right there. So y plus 10 equals 2 times y plus 2 minus 8. I'll distribute the 2. So I've got y plus 10 equals 2y plus 4 minus 8. We'll combine like terms and move some stuff around here. I'm going to go ahead and combine like terms here. So that's 2y minus 4 equals y plus 10. I will add the 4 to the other side, so that gives me 14. I'll subtract y, that gives me y. So y in this case is 14. Then I'll just plug it back in to find x. And in this case, 14 plus 2 gives me 16, so x equals 16. Same idea here. We want to find x and y. So here we'll set this part equal to this. So y equals x plus 1. And then we have this, so 2x equals 3y minus 7. We'll take what y equals, and we'll plug it in for y right here. So that's 2x equals 3 times x plus 1 minus 7. So we're going to distribute. 2x equals 3x plus 3 minus 7. Combine like terms. We've got 2x equals 3x minus 4. I will subtract the 3x over, so I've got negative x equals negative 4. So in this case, x equals a positive 4. Then I'm just going to plug it back in to see what I get. Well, 4 plus 1 tells me y equals 5. All right, the next part is the wrap-up. Go ahead and pause the video, solve the wrap-up, and then unpause it to check your answers.